I'd like to talk with you about the midpoint formula. Recall that the midpoint of a line segment is the point on the line segment that is equidistant from the endpoints. So if, for example, if I have this line segment with endpoints P1 and P2, the midpoint would be this point right here in the middle, where the distance from M to P1 is equal to the distance from M to P2. So let's look at an example. We'll let P1 be the point 2, 1, and we'll let P2 be the point 6, 3. So let's plot that on this grid. P1 is this point right here, and P2 is right here at 6, 3. So let me draw this line segment. Now, I understand that I haven't provided the formula for you, but let's just look at the graph and see if we can determine where the midpoint would be. I would say it's about right here. We'll call that M. And looking at our graph, it looks like the ordered pair is 4, 2. Now let's compare that point to the endpoints. So we're saying the midpoint is 4, 2. Look at the x-coordinates of P1 and P2. They were 2 and 6. And the x-coordinate of the midpoint was halfway between the 2 and the 6. In other words, it was the average of 2 and 6. Similarly, if we look at our y-coordinates, we have 1 and 3. The midpoint had a y-coordinate of 2, exactly halfway between the 1 and the 3. In other words, the average of 1 and 3. So let's write the midpoint formula using that idea of average. So let me come back over here on the left. We're going to say that P1 is the point x1, y1. And P2 is the point x2, y2. The midpoint can be found by averaging the x-coordinates. So that means we add x1 plus x2 and divide by 2. And we average the y-coordinates, y1 plus y2 divided by 2. And there is our midpoint formula. Let's practice finding the midpoint with this example. The endpoints of our line segment will be -3, 11, and 15, 27. So our midpoint will be the average of the x-coordinates. So that's -3 plus 15 divided by 2. And the average of the y-coordinates, 11 plus 27 divided by 2. Let's do the arithmetic. So we have 12 over 2, and we have 38 over 2, which gives us the ordered pair of 6, 19. And at a quick glance, those do seem to be the numbers that are between -3 and 15, and 11 and 27. Let's look at another example. And let me remind you with this example that sometimes you can see the midpoint pretty easily without the formula. Let me give you this example. We'll let P1 be the point -10, 102, and we'll let P2 be the point -11, 104. Keeping in mind that the midpoint is the point that is halfway between those 2 points, let's look at our x-coordinates. We have a -10 and a -11, halfway between that you might recognize as negative 10.5. And we have those y-coordinates 102 and 104. We know that the number halfway between those two is 103. And that, in fact, is our midpoint. I just wanted to remind you that on some simple problems, you might just be able to jot it down without the use of the formula. But let's confirm that the formula works. Remember, it is the average of the x-coordinates. Negative 10 plus negative 11 divided by 2. And the average of the y-coordinates, 102 plus 104 divided by 2. So we would get negative 21 halves and 206 halves. And we could replace that negative 21 halves with the decimal negative 10.5 if we like. And 206 over 2 is 103. So notice that's just what we would expect. But this was a simpler problem. Let's do one last problem where the numbers aren't quite as friendly. For this problem, we'll let the endpoints of the line segment be negative 10.4, negative 17.8, and 1.3, negative 2.3. And our goal, again, is to find the midpoint. Well, on this one, I'm not going to just take a stab at it. I'm going to use my midpoint formula. We know the midpoint is the average of the x-coordinates and the average of the y-coordinates. So that means we're going to add negative 10.4 and 1.3, and we'll divide by 2. We'll add negative 17.8 and negative 2.3, and we'll divide by 2. We have some arithmetic to do. So for the x-coordinate, we'll have negative 9.1 divided by 2. And for the y-coordinate, we'll have negative 20.1 divided by 2. So finishing, we'll have negative 4.55 and negative 10.05. And we have found the midpoint. So the beauty of the midpoint formula is it doesn't matter what the endpoints of the line segment look like, we can always find that midpoint.